Okay, so we're going to look at the definition of the power set, and we're going to look at some examples illustrating how the definition works. So the definition goes as follows. We're going to let A be a set. We know the power set of A is a set whose elements are the subsets of A and is denoted power set of A. Thus, the power set of A is equal to all the B's such that B is a subset of A. So we can see that the elements of the power set are those subsets of A. So let's go ahead and do some examples. So we know, let's look at the empty set, right? Well, we know that the empty set is a subset of itself, right? Because the empty set is a subset of any set, including itself, right? So this means that the power set of the empty set is going to be the set containing the empty set, right? Because we know the empty set is a subset of the empty set. So that B here is going to be the empty set. Okay, let's go ahead and look at the set containing A, right? So let's think about all of the possible subsets, right? Well, we know that the empty set is a subset of the set containing A, right? Because the empty set is a subset of any set. And we know that the set containing A is a subset of itself. We know any set is a subset of itself. So this means that the power set, right, the power set of the set containing A is going to be the set containing A and the empty set, right? Does that make sense? Okay, so now we're going to look at the set containing A and B. So the possible subsets of this are, we know that the set containing A is a subset of the set containing A and B. We know that the set containing B is a subset of the set containing A and B. We of course know that A and B is a subset of itself. And we know that the empty set is a subset of the set containing A and B. So this means that the power set of the set containing A and B is equal to the set containing A, the set containing B, the set containing A and B, and the empty set. Okay, so notice when we had no elements, right? When we had the empty set, the power set of the empty set gave us one element. So notice that the cardinality of the power set of the empty set is equal to 1, right? Notice that the power set of a set containing one element gave us two elements. So the cardinality of the power set of A, right, gave us 2. Okay, and for the last one, when we had two elements, right, we know that the power set of a set containing two elements gave us 4. So the cardinality of the power set of A and B, right, gave us 4. And hopefully you guys can see the relationship. What the relationship is we know that if A is a set containing A sub 1, A sub 2, dot, 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 A sub n, this implies that the cardinality of the power set of A would give us 2 to the n, right? Notice when we had the empty set, it gave us one element, right? So when we had 0 elements, we had the power set give us one element. And notice this is 2 to the 0, right? 1 is equal to 2 to the 0. When we had one element, the power set gave us two elements. And we know this is equal to 2 to the 1, right? When we had one element, the power set of one element, a set with one element, gave us two elements, which is 2 to the 1. And when we had a set with two elements, the power set of a set with two elements gave us 4 elements. And we know this is 2 to the 2, right? So In the next video, I'm actually going to prove this relationship here, that if there are n number of elements in A, then the cardinality of the power set of A would give us 2 to the n.